AsapMath.
Hey, what's going on everyone? I'm Olivia from AsapMath. Today's video we are going to discuss about the factorization of quadratic expressions. A quadratic expression is any mathematical expression whose power or degree is 2. We will discuss few examples to understand the concept of factorization of quadratic expressions. Moving on the example 1. Answer for this question is x minus 3 into x plus 2. Now let us see how to obtain this answer. We have to find two linear expressions where their product is equals to x squared minus x minus 6. First, we should take the multiplication of coefficient of x squared and constant term. Here it is minus 6. Then we should take the coefficient of x term. It is minus 1. Now we have to find two factors of minus 6 such that their addition is equals to minus 1. Minus 3 and plus 2 satisfies both conditions. Now we can fill two linear expressions with these factors. We have found the answer. To verify our answer is correct, we can expand these two expressions. It shows that our answer is correct. Let's consider another example. First, we should take the multiplication of coefficient of x squared and constant term. Here it is minus 96. Then we should take the coefficient of x term. It is plus 4. Now we have to find two factors of minus 96 such that addition of two factors is equals to plus 4. Plus 12 and minus 8 satisfies both conditions. Now we can fill two linear expressions with these factors. To verify our answer is correct, we can expand these two expressions. It shows that our answer is correct. We will consider a different example now. In previous two examples, coefficient of x squared is equals to 1, but here it is equals to 2. So, when writing linear expressions, we can use 2 as coefficient of x in any expression. Here we will put 2 in first expression. Other steps are almost same. First, we should take the multiplication of coefficient of x squared and constant term. It is equals to plus 12. Then we should take the coefficient of x term. It is plus 7. Now we have to find two factors of plus 12 such that addition of two factors is equals to plus 7. Plus 3 and plus 4 satisfies both conditions. Can we directly use these two factors to complete linear expressions? No, we can't. That's because we have already considered the leading coefficient when writing two expressions. Now, what we want to get is plus 3 and plus 4x terms. If we complete first term with plus 3, from that we can get plus 3. Now, to get plus 4 from second expression, we just need only 2 because there is already 2. 2 times 2 will result in 4. Did you get it? We can't directly use two factors because leading coefficient is not equals to 1. We can expand the result to cross-check our answer. If we just go back to the example 2, we have almost followed the same procedure without our intention. But there as coefficient of x squared is 1, it makes no difference. We will consider another example. Here also, leading coefficient is not equals to 1. It is 5. So, when writing linear expression, we can use 5 as coefficient of x in any expression. Here, we will put 5 in first expression. Then, we should follow the same steps. First, we should take the multiplication of coefficient of x squared and constant term. It is equals to plus 10. Then we should take the coefficient of x term, it is minus 7. Now we have to find two factors of plus 10 such that addition of two factors is equals to minus 7. Minus 2 and minus 5 satisfies both conditions. Now we know that we can't directly use these two factors to complete two expressions. Now what we want to get is minus 2 and minus 5 x terms. If we complete the first expression with minus 2, from that we can get minus 2. Now to get minus 5 from second expression, we just need only minus 1 because there is already 5. 5 times minus 1 will result in minus 5. What if someone complete the first expression with minus 5? Yeah, we can do that also. If we used minus 5 to complete first expression, then now we have to form minus 2 from the rest. If we are to make minus 2 from the second expression, we should complete it with minus 2 over 5 such that multiplication of 5 and minus 2 over 5 is equals to minus 2. Just expand this to check our answer. Moving on to example 5. We can repeat the above discussed steps. Two relevant factors that satisfied conditions are minus 4 and plus 5. Now, what we want to get is minus 4 and plus 5 x terms. If we complete second expression with minus 1, from that we can get minus 4. Now, to get plus 5, we can complete the first expression with plus 5. Here also, one can complete the first expression with minus 4. Then, from second expression, we have to get plus 5. As already 4 is there, we have to complete it with 5 over 4. Both give the same answer, but you can see that first method is much easier. So far, when factorizing, we use the leading coefficient only in one expression. We also can factorize and use it in both expressions. Here as leading coefficient is 4, we can factorize it and use it in both linear expressions. So now, completing the expressions, we must be careful enough to complete them such that their products are equals to minus 4 and plus 5. Let's consider another example. This can be factorized into 3 different ways. From the 3 different ways, one method is much easy and other are little bit difficult. So we should know which method to be selected. Possible 3 methods are shown on right top corner. We can identify 2 factors by following the previously discussed steps. Two factors are 18 and 2. Now we already know that we want to get 18 and 2 near x terms. So, if we choose first method, it is difficult to get 18 or 2. We must multiply 12 by a fraction to get 18 or 2. So, let's move to second method. Here also difficult to get 18 or 2 because again we need to multiply 4 by a decimal number to get 18 or 2. Only left option is third method. Yeah, it is feasible because we can get 18 by multiplying 6 by 3 and 2 by multiplying 2 by 1. So, third method is the easiest way. After figuring out 3 possible ways, we can get coefficient of linear expressions as 12 and 1, 4 and 3, 6 and 2. From these sets, we have to get 18 and 2. So, it is pretty easy. We have to select set 3 because 6 times 3 is 18 and 2 times 1 is 2. Try to figure out this example. There are 4 ways to write linear expressions. Their coefficients would be 36 and 1, 18 and 2, 6 and 6, 9 and 4. Now we want to get minus 9 and plus 4 from this set. So we have to select last set because 9 into minus 1 will give us minus 9 and 4 into 1 would give us 4. So this method is much easier. In this video, we have discussed more easy ways to factorize quadratic expressions. These expressions can be converted into quadratic expressions and factorizing can be done as we discussed. We will prepare a video covering these areas.
Thanks for watching. If you like this, make sure to subscribe for more.